So in this video, we are going to be doing the Mod 2 exam review. Um, so please at this time, open up your iMath and open up the Mod 2 exam review and let's take a look. So the first question here says to recall that a quantity is an attribute of an object or situation that you can imagine measuring. And which of these are clearly defined quantities? So if we take a look, the width of a computer screen could be a quantity, but since we don't know, should we measure it in inches or centimeters, that one's out. The color of a candle's wax, that is a color, not a quantity. The height of a candle in inches, since they've actually specified the fact that we are measuring a height and we've measured the units in inches. The brand of a computer isn't going to help us. The weight of a new car in pounds before being sold is a good one because of the fact that it is clearly defined and it is a quantity. And finally here, the make of a car. The make of a car is not a quantity. So that is what they mean by this first question. So now let's move on to the second question here. It says, let's scooch it in slightly, that Nichelle walks from her house to a bus stop that is 460 yards away. Now, the one I'm doing here is a sample of a question that a similar question on your review. Your review and my review might be slightly different, but this should get you an idea of what's happening. It says, so Nichelle walks from her house to a bus stop that is 460 yards away. So I like to make a little picture, and we'll put house and bus stop, and then 460 yards. Okay. Which of the following distances vary as Nichelle walks to the bus stop, and which of them are fixed? Well, the distance between Nichelle's house and the bus stop, that is something that never ever changes. So that is going to be fixed. Oh, I'm sorry. Put it in the wrong spot here. Nichelle's distance from the bus stop, because she is walking away from that distance will be varying. The distance between the bus stop and the stop sign south of the bus stop, that is something that is fixed. And then Nichelle's distance from her house, because she is walking away from her house, that is varying. Okay, now let's think about the next thing for a minute. It says, as Nichelle's distance from her house increases from 80 to 170, her distance from the bus stop varies from what to what? Okay, so let's go back up and revisit our picture for a moment here. So if she is 80 yards from the house, if you do 460 minus 80, that means she has 380 yards left to get to the bus stop. So let's put the 380 there. Now, your numbers might be a little different from mine, but that's how you're going to walk through that process, okay? And then the next one says that she is 170 yards, so let's draw that. So if she is 170, sorry, my scale is not accurate, but it's just kind of a placeholder for my information. And that means that she would be 290 yards away. So we can see that as her distance from her house increases, the distance from the bus stop, it decreases. So that is a little bit about that question. let's go to this next one. Now I'm going to start at the top and then we'll work our way to the graph, okay? Okay, so it says a tank contains 24 gallons of water. Okay, so let's just, make a little picture. Here's a tank of some sort, and it contains 24 gallons. And all of a sudden, water begins draining at a constant rate. So the water is draining outward at a rate of 2 gallons per hour. And I put that negative there to display the fact that the amount of gallons will go down, that negative, okay? So then it says that let T represent the number of hours. So it's a good idea to write that down. And then V is the volume of the water in the tank. So it says write a formula. Now when it says to write a formula, we need an equal to sign in there. And so we know that our volume started at 24, and is going down by 2 every single time. And so because of that, we want to write that as volume. Started at 24 and is going down by 2 every hour. So that would be the expression they're looking for. So then it says, as T increases from 2 to 5, V varies from what to what? Well, in our equation, let's plug in 2 and let's plug in 5 and let's see what's happening. Well, if you plug in 2, you get 24 minus 4 or 20. So that would be the answer here. And if you plug in 5, you get 24 minus 10 or 14. And we should say that as time increases, the volume should go down since it's draining out. We should see it decreased from 20 to 14. So if we revisit that 2 to 5, the delta T, that change in time, was 3 hours. And the change in volume, if we just do that 20 minus 14, it went down 6. So the change in volume was 6. And one thing I didn't do right, I'm so sorry, let's fix it. It's always ending minus beginning, and that's why you get a negative gallons. Okay, so that being said, it says graph below represents the relationship between T and V. Plot the vectors using dotted rays to represent the changes you computed in part C from the reference point when T is 2. Now remember, when T was 2, we found out that the volume was 20. So what you would do is you go over to your graph, start your vector at the point 220, and then we're going to an x of 5. So our delta time, or delta T, I went a little too far here. Let me erase that. Our delta change in time was 3 units. So 1, 2, 3. And then we'd start here over again, and we would go down 6. Now, be careful. They're counting here by ones. You'll notice that. But here it's 2, 4, 6, 8, 10. So if we go down by 6, this is 2, 4, 6. But you should hit the line again, okay? So that is what they are expecting to see for D. So there's problem number 3. Now let's take a look at problem number 4. It says that a 17-inch candle is lit and steadily burns until it is burned out. So I'm going to draw a picture of a little candle here. And I am going to mark along the side here that this is a total of 17 inches when we started. Now, B is going to be the burned length. In inches. And R is going to be the remaining length. In inches. And it says to write a formula that expresses R in terms of B. So if you see that, write a formula at R in terms of B. You're going to start out with the R, and we need an expression now that relates that to B. And so we know that if I have burned some length B, that this has to be what's left. So it would be our original 17, take away the B that's been burned. And so that's what we want right here. Now let's go to part B. It says when 6.5 inches have burned, so that would be our B value, 6.5 inches. The remaining length of the candle is blank. Well, we have a nice formula, so just take that from 17. The answer would be 10.5. Now remember, your numbers might be slightly different from mine. So if your candle, my candle's 17, your candle might be 15 or 14 or 12. So adjust it as you're doing your review, but this will give you a sense of what you need to do. Okay. It says, therefore, the point blank should be on the graph. So B would be our independent variable. That would be our X. R would be our Y. So that means that if B was 6.5, R would be 10.5. Okay. So it says on the graph below, represent the linear relationship between R and B. So we just need to graph a point, and then maybe even a second point. We can also use the equation. So we have this to help us. We also have this equation. Now, what we know about linear equations, the starting value or the starting height was 17. They have been counting by ones in both our R and our B, our X and our Y. So we can start at 17. Our slope is -1, so we can go down 1 over 1, down 1 over 1, and so on. And you can make your line. There we go. Okay. For iMath, as you graph the line, you are just going to need 2 points. So I would use that 6.5, 10.5, or, if, think about this equation here. We know if we plug in 0, here, let me use the correct variables. We start, sorry about that. If we start at 0, we're at 17. If we burn 1 inches, we're at 16. So you can find any 2 points and graph it. Now, but part 2 says, plot the point that represents when it is 9 inches tall after 8 inches of burning. So remember, that is technically the 0.89. So on the graph, make sure you use that point application, and we would go to the 0.89. So that is example 4. So now let's move on to example number 5. It says, question number 5. It says that Guten and Pavati are 240 meters apart when they start walking toward one another. So I'm going to draw a little picture here. And I'm just going to put their initials to remind me, you know. And then I'm going to put 240 feet. Okay. Pavati walks twice as fast as Guten. So when Guten travels x feet, Pavati travels 2x feet. So if we think about it, Guten travels x, Pavati travels 2x. What's left right here is the total we've got minus off x and 2x. X and 2x totals up 3x's. So an expression in terms of x to represent the total number of feet that Guten and Pavati have walked toward one another. Guten has walked x, Pavati has walked 2x for a total of 3x. So the expression to represent, so this is what you would enter. The expression to represent the distance in feet between them, that's where the 240, take off the 3x that they've walked inward, would that's what they would want there. And then it says, let D represent the distance in feet between them, write a formula. Now remember, D in terms of x means we want it to be D equals x, and we have this already. So that would be 240 minus 3x. And then it says in the above formula, what is our independent variable? And that would be x. So your independent variable would be whatever they say the words in terms of. In this case, it was x. So there's example 5. Let's move on to 6. It says the points given satisfy a linear relationship between the variables x and y. What is the constant rate of change? The constant rate of change when given 2 points is just our slope. It is delta y divided by delta x, or y2 minus y1 over x2 minus x1. Now, beside the problem for an equation like, excuse me, like this one, if you go to type it in, you know, you do have the option to use that little equation editor. That's that little yellow box, which does allow you to throw some, you know, fractions that look nicer, square roots and things like that. So be mindful of that. You can use that. But in this case, let's label our points, x1, y1, x2, y2, and let's plug those in. So that would be negative 29 minus negative 2. Let's just make that plus 2. Over 4 minus negative 5, which would be plus 5. You're always changing the sign of your x1 and y1. When you subtract, you add the opposite, so change that sign. So that would be negative 27 over 9. Since 27 is perfectly divisible by 9, go ahead and divide. So your answer is negative 3. Now it says to write a formula that expresses delta y in terms of delta x. Okay, so we know that delta y over delta x is negative 3. So what they want is they want you to write delta y equals negative 3 delta x. Okay, so it's really just delta y equals negative 3 delta x. Write a formula that expresses y in terms of x. Now, we don't want deltas anymore. We want y's and x's. So that's where we use y minus y1 equals m times x minus x1. So we have 2 points to choose from. Doesn't matter which. I'm just going to use the slope I got, negative 3, that constant rate of change, and my point, negative 5, negative 2. Okay, so let's do that. So we get y plus 2 equals negative 3 times the quantity of x plus 5. Now, if we want to solve that for y, we need to distribute the -3 and subtract off whatever this is, or do the opposite, which is subtraction by 2. So our equation is y equals -3x minus 17. Now, once we get that formula, then it's just a matter of plugging in the value when it comes to part T. It says, what is the value of y when x is 1? Mine says 108, yours might say something different. Okay, so really the y value is just going to be -3 times 108 minus 17. So just follow your order of operations. So if we do -3 times 108 minus 17, we get -341. Okay, so that is problem number 6. Let's look at problem number 7. It says the points satisfy a linear relationship between two variables. And then they ask us a lot about what are the points when this is this, meaning we need a formula. We needed the equation of the line. So let's find y minus y1 equals m times the quantity of x minus x1. And it is going to allow us to find all a, b, and c. But first, we need the slope. We don't have that constant rate of change. We can't do that. So if we label our points x1, y1, and x2, y2, we get the slope is 30 minus 6 over 3 plus 5, or 24 over 8, or positive 3. So I'm just going to use the point 330 and the slope of 3. Now you could use either point, that's just the one I'm picking at this particular time. So we get y minus 30 equals 3 times the quantity of x minus 3. So we get y minus 30 equals 3x minus 9. If we add 30 to both sides, we get y equals 3x plus 21. Okay, now that is our formula that we get to use to answer the questions A, B, and C. So A says, what is the value of y when x is 40? So if we put in a 40 where the x is sitting, we get 120 plus 21, which is 141. Now again, your points might have been a little different than mine. You're going to do the exact same procedure. And then we would do the same thing for B. We would plug in 95. So 3 times 95 plus 21 in my case. Yours is going to probably be a little different. We get 306. Now the one that's different is C. It says, what is the x value when y is 30? So this time we know the y value has to be 30. So let's put 30 there. And then it's an equation. You just got to solve. So I'm going to subtract 21 from both sides. I'm going to divide by 3. So the answer is 3. So there's example 7. Let's take a look at 8. It says we have these 2 points on a graph. What is the constant rate of change? Well, they just want the slope, which is y2 minus y1 over x2 minus x1. Now it's helpful to go from left to right, so the graph gives us that representation, but it doesn't really matter. But I am going to make this one on my x1, y1, and this my x2, y2. So the change in y is just going to be 9.85 minus 2.2. So use your y values that you were given. So mine was 7.65. And then my x's would be 3.2 minus a negative 1.9, so change that sign. So 3.2 plus 1.9 is 5.1. So my slope is 7.65 divided by 5.1, which is 1.5. Okay, and then one helpful hint is our linear equation. It has a positive slope because it's going uphill, so you should get a positive number. you only get a negative number if your line looks like that, if it's going downhill from left to right. Now it says to write a formula. So that comes back to y minus y1 equals m times x minus x1. So I have a y1 and x1, why not use it? So y minus 2.2 equals 1.5 times x plus 1.9. If we distribute the 1.5 with the 1.9, we would get 1.5x and then 2.85. And then add 2.2 to both sides. So we get y equals 1.5x plus 5.05. So that's what they were looking like there. And then C, just, you get to use that formula now that you have it. So if we have that nice formula, we're going to put our x value right there of 110. Follow your order of operations. We get an answer of 560.55. So that is example number 8. I can leave that there for a sec. Example number 9. It says Nuki and Karen are 210 feet apart and they walk toward one another. Nuki travels at a constant speed of 3.5 feet per second and Karen travels at a constant speed of 5 feet per second. T is the number of seconds. Write an expression in terms of T that represents the number of feet that Nuki has traveled since he started walking toward Karen. So if we draw a little picture, we'll put Nuki and Karen, 210 feet. The distance that Nuki walks, because he or she is going at a 3.5 feet per second rate, distance equals rate times time. So after t seconds, he would have walked 3.5 t, and Karen would have walked 5 t. So that's what they want here. So Nuki has walked 3.5 t feet. Write an expression in terms of t that represents the number of feet that Karen has walked. That's 5t. And write an expression in terms of t that represents the distance between them. So if we took the total 210 and we took off the 5t that Karen walked and the 3.5 t distance that Nuka walked, we would get, it would be 210 minus the total 8.5 t's. And how many seconds will they reach each other? Well, we want that distance between them, that expression we see here, to be nothing. So just take 210 minus 8.5 t and say, I want that distance to be nothing, and solve for t. So we would get 210 equals 8.5 t. 210 divided by 8.5 is 24.70588 seconds. I don't know how long they wanted me around to. You probably even could put in 210 divided by 8.5 for iMath, and I think it does count that sort of thinking. Okay, so there's example 9. Let's look at 10. It says Linda is riding her bike to the restaurant. She rides at a constant speed of 28 feet per second. The restaurant is 6,422 feet from her house. Let t represent the number of seconds since Linda has left her house. And let d represent Linda's distance from the restaurant. Okay, so the restaurant is that many feet away. Okay, so here's her house, and here's the restaurant. And we're going to let t represent the number of seconds since she's left her house. She's going 28 feet per second. So this would be 28t. And it says to match each description with the appropriate description from the list. So T is the number of seconds it takes, or I'm sorry, T is the number of seconds since she left her house. That's how it's defined. So this one is B. 6,422 minus the 28T is the the distance she has to get to the restaurant yet. That would be right here. So that's E. 28T, remember, was the distance she has from her house, the distance that she is riding. So that's F. 28 is her constant rate of speed, what she can ride in 1 second. So that's D. And then that division would be the total number of seconds it would be to take to get to the restaurant. So that would be A. Okay, and then it says to write a formula that gives Linda's distance from the restaurant in feet in terms of the number of seconds she left her house. Well, if we want to know the distance from the restaurant, it is always going to be the total that it started to be minus off how much she has ridden. So that's the formula they are looking for. So there is example 10. Now let's go to example 11. It says, suppose that the constant rate of change of y with respect to x is 5. So it's not a bad idea to write that fact down. And it says, which of the following statements are true? The value of x is 5 times large as the value of y. Not necessarily. The change in y over the change in x is 5. Is y equal to 5x? Maybe. That is one option where we have a delta y over delta x that's 5, but it's not always true. So I would say no there. The value of y is 5 times as large as the value x. Again, no, maybe. But the one we know for sure is this one. And other than that, let me read them one more time and see if there's anything else we really know. There might be one other one. Let's see. The change in y is 5 times, oh, okay, the change in y is 5 times the change in x. I do like this one too. That's just saying this in words, and it has to use the change in that delta or the words change in. Okay. Okay, let's look at this one. It says the applet below shows a tree in the shadow of the tree cast. You can adjust the heights of the tree, and the applet will show the tree's height as well as the length of the shadow that the tree shows. And it says to drag the point around. Okay. Now mine is a paper copy of this, so there's no dragging that I can do. But one thing that they are trying to get you to see, okay, is the proportionality of this, okay? So let's say that you're, like mine, it's 8 feet and 6.4 feet. So what's interesting is that proportionality is always true. So what you can do here, and you'll have the little applet to drag and drop, so just do what they say here. So if we drag till this tree is 6 feet tall, my picture currently shows that 8 feet on the tree is 6.4 on the shadow. So a 6-foot tall tree would give me that size shadow, okay? So for me, again, my ratio might be a little different than yours. We would get that it was 4.8 feet. And then if we stretch the tree to 11.5, we would use that same proportion, except now use 11.5. And this time I got 9.2. So if we want to know for any height of the tree, the height, let's make a little equation. If we know, so the height of the tree versus the height of the shadow. The height of the tree will be what times the height of the shadow. So if we cross multiply, it's 8 over 6.4 times the shadow would be the tree. So it would be 8 divided by 6.4 for my case. So it's just for yours, tree divided by shadow. So in my case, 8 divided by 6.4 is 1.25. So if the tree's shadow is 20.3 feet long, how tall is the tree? So the tree is always 1.25 times the shadow. We got a formula now. The tree is 1.25 times the shadow. So if the shadow is 20.3, just take 20.3 times 1.25, and we get 25.375. So that is example number 12. It says Aiden is stretching at the trailhead and starts walking down the trail as Lucy walks in the same direction. The graph shows their distances along the trail from the trailhead in feet versus the time in minutes. So if we look, okay, so this is the time, this is the feet they have walked. So at 20 minutes, Aiden has walked just over 6,400, and Lucy has got all the way up to 8,000. So since this height is different, their distance is higher. So in mine, it would be Lucy has walked further. So we're just checking at the 20-minute mark, who's at the higher number of feet. Okay. At 16.25 minutes, the two graphs intersect. So I'm going to kind of highlight that point. Which of the following best describes what is happening at that instant? At that instant, their heights are the same, so they have walked the same distance. So they have caught up to each other. So if you'll notice, Aiden was higher than Lucy until that spot. So he was going a longer distance, but Lucy catches up. So I would say that it would be this one. Again, your names might be different. Your graph might look a little different. Which of the following statements are true regarding the 20 minutes of Aiden and Lucy's walk, shown by the graphs? So what's interesting is if they say they have the same average speed, they have who has a greater average speed. Lucy's walking a constant. Okay, so Lucy's walking a constant because she's at that perfectly straight line. We can definitely say that. But let's draw a line between Aiden's beginning position and final position. Okay, so let's look at that. So if we think about the slope, this slope, rise over run, constant rate of change, of the blue line is bigger than that slope. So on average, Lucy was at a higher speed than Aiden, okay? So there's example 13. Let's look at example 14. It says a particle falls from a height of 20 meters above the ground. The graph shows the particle's height above the ground in in meters in terms of the seconds t since the particle started falling. So you'll notice that our t, this is 1, 2, so they're almost counting by halves. And then this is 2, 4, 6, 8, 10 meters. So we can even remind ourselves this is seconds and this is meters. Okay. What is the particle's average velocity as t increases from 0 to 2? So let's mark the points on our graph at 0 and at 2. Now, we need the average velocity is just the slope. It's the meters per second between these points. So you can do it two ways. You can try to count out the slope from the graph, rise over run, or you can do the change in y over the change in x. Let's do that. The y has gone down by 2. Sorry about that. That says -2. The time, the x in this case, if we count like they did, 1, 2, was 2 seconds. So that is -2 divided by 2, or -1 meters per second. But now they want us to do the same thing between 2 and 4. So I'm going to erase what I got here. And I'm going to go from time 2 to time 4. Now I'm going to show you another way, because you're obviously not going to be, you can't really graph or write on it. You can draw like a graph on the side, but yes, we can do rise over run. That's perfectly legit. So feel free if you can calculate that out. But this is the point 218. This is the point 412. So if we do y2 minus y1 over x2 minus x1, I'm sorry, that's an x, then you can do it like that as well. So that would be -6 over 2, or -3 meters per second. So anytime they say the constant rate of change, or the average rate of change for a graph that has a curve to it, you're just connecting the line that connects those two. And so you're just doing the slope equation for those two particular points if you connected them with a line. So that is example 14. Let's look at 15. For time's sake here, because this is a pretty lengthy video, it says, what is the distance between the points? I'm going to do one that should clarify it. Let's do one that has some negatives to it. Let's do B. So the distance formula is what you need for this. That's the square root of x2 minus x1 squared plus y2 minus y1 squared. And you're going to square root that answer. So for this particular, we're going to do B alone, okay? For that particular one, you're going to label your points and plot them in. So our distance would be the square root of -3 minus 1 squared plus 2.5 minus 5 squared. Now keep your value in parentheses so that you remember you have to square a negative or a positive, and that's going to become a positive. So in this case, we get 16 plus 6.25, or the square root of 22.5. So that's just a basic distance formula. Make sure you have that formula memorized for the test. 17, the center of a circle is at 1, 2, and a point on the circle is located at -6, 2. What is the radius and what is the equation of the circle? Now, the radius of a circle is the distance between any point on the circle and the center. So we're going to do exactly what we did for 15. I'm going to call this, I'm going to call the center, let's call the center our x1, y1, and let's call the other point x2, y2. And let's do our distance formula. If we plug in our points, we get -6 minus 1 squared plus 2 minus 2 squared, which is -7 squared plus 0 squared, which is the square root of 49, or 7. Now the other formula that you want for the equation of a circle is that R equals, so it would be x minus h squared plus y minus k squared. Square rooted is equal to R. So our R is 7. Our HK is, in this case, the center, which is located at 1, 2. Okay. So you just pop those things into the equation. So it's 7 equals the square root of x minus 1 squared plus y minus 2 squared. And that would be the equation of our circle. So that is example 16. And you know, this is a great review for you to use for the test. There you go. Good luck.